Hey, Zhamak, how you doing?
I'm doing great. How are you, Joe?
Great, great. Good to see you again.
Good to see you too.
Yeah, so some pretty big news. It looks like this great book, by the way, and great idea, is becoming a reality now. So it's pretty
Well,
awesome.
it has been a reality, right? It's we part of the book was the was containing the learnings of what was happening on the ground building. Uh,
Hmm.
I think with any new paradigm or innovation or new way of thinking, we kind of develop a new mental model, we develop a new language, we use the tools we have, they kind of work, they kind of don't work, and then we need new tools to reshape our behavior and work in new ways closer to the paradigm. And I think that's just a natural evolution of
Right,
creating new ideas and then creating tools that fit those ideas. And it's just it's that phase of the reality maybe we're in.
right. Yeah, let me just share my screen real quick. Just want to show what we're talking about here. So yeah, thanks to the audience for showing up. Got a lot of interested people. Obviously, data mesh is well, it's captured a lot of imagination. But next, let me go to the top here first. Uh, next data OS. What walk us through this? What is it, and what's the mission?
So first and foremost, I have a I guess maybe question for the audience. We can't really chat here with the audience, can
Oh,
we?
it's like a chat bar on the side. You're not gonna. They can chime in over chat. So
Yeah. So there was a what does this thing shows? Like, does can anybody guess this moving petals? What does it represent? So I just put that out. There was a design behind. There was some ideas behind the design, but just let's move on.
okay.
Right. Just keep audience busy. So yeah. So when the idea of the data mesh came to exist, it was the main, I guess, the idea behind it was decentralization of ownership of data, as in people that are closer to the data, that can model it, that can take care of it, can write the code that actually maintains that data, they are responsible for it. But then there is a gap to, okay, say that's the idea, to get to a place where analytics, machine learning training can run on this autonomous, set of data sets that have been maintained by other people. So there's still a large gap to get there. And what happened was, people like this idea of decentralization of data ownership, but what did we have to do? What tools we had at our disposal to implement it? Those tools were still tools designed for either you centralizing data in a warehouse or a lake, or you're still building a pipeline to move the data from this source to this destination. So the technology that we had was built for this still fairly pipeline oriented thinking, task oriented thinking, and centralization. And then, only then, you can then run, kind of analytics and machine training pipelines off the back of that. So the next data OS tries to change that and say the atomic units of data that we can use as value, use for analytics in a decentralized way or machine learning in a decentralized way. Those atomic units are something new. Those primitives are different. We call them data products. I mean, they were always called data products, but they were never manifested as an atomic unit. They were manifested in the last few years as metadata that brings together disparate pieces of technology, like where the data lives and where its metadata is and where its governance policies are. It was a metadata pulling it together. We're actually making it real. We say this: we need a new primitive to work with data, to share with data, to connect data. And given that we have a new primitive, we almost need an operating system to build it, share it, connect it, find it, discover it. So that's kind of the idea here, that bridge the gap between what we want data product to be, and actually codify that, right? It's a codification of the data product in the book. And then you need we think about it as just a container Unix process, however we want to call it. Like the analogies of the past are probably quite poor, but and then you need an operating system to build it. So we can kind of go deeper what these things are, but hopefully that makes sense.
Yeah. Well, let's go deeper into that too. Like, what is an operating system? For data. This is a very interesting concept.
Yeah, and I know there are folks out there that use this language, data operating system. I use the kind of, I guess, the data mesh operating system here. It's just an analogy to how operating systems work. It resonated with me. So let's unpack it a little bit. So the job of an operating system, in a way, it's creating an abstraction on other primitives such as foundational utilities like the CPU and the disk and the peripherals that we have and the communication between them, and create a layer that abstracts those diverse, I can run a Mac or Linux, and I can run that operating system on an Intel processor, an M1 processor, or different processors, right? So you have this kind of layer of abstractions that to a degree isolates you from those primitives that need to work together for you to actually build applications as a developer on top or use applications on top. So in our case, it's somewhat similar that we say, okay, and let's actually move on a little bit further with that analogy and say, if the job of this operating system, we run operating systems, we build applications on top. The units of applications often are, Unix processes, or then interfaces, right, for those processes to work with files or share data and so on. So it's I guess in a way, it's a similar concept that we try to not fully abstract away, maybe abstract is not, but allow people to work with different types of technologies and different platforms. One of the main problems we see is that I want to have data mesh, and I want to use that paradigm universally in my organization, but half of my organization is on Snowflake, the other is on Databricks, the other one is on native structure on Amazon. So the job of an operating system, in a way, is to create a unified experience as a developer, data user, regardless of what your technology is. So that driver mentality, the driver model, that we have a driver interface to storage, and then you go and implement it, is part of it. I'm going too much details than probably I want to go, but nevertheless. So we want to, you want to respect the millions of dollars that people spent and the innovation that has been done in parallel processing in large scale storage. We would not want to replace that. We want to tap into that, but for building a new developer experience. Again, I emphasize that a set of tools, a set of, your operating system gives you a set of tools, right, to work with processes and build them and so on. So a set of tools that allow build this idea of the data product to life, isolated from the technology that you're on, and allow that data sharing for analytical purposes across different technology.
That's really cool. Getting a lot of questions here. I know, and for the audience, we only have until the half-hour mark for this. And so, are there any questions that I don't know if you can see the chat here, but I can throw some
I like Dylan's question. There's a question around decentralized across different organizations and companies.
Yeah, that's a good question.
It's a good question. I think a lot about this. We don't want to build yet another technology that we say, look, you can have decentralized data sharing as long as you use our technology,
right,
as long as you use our platform. So we're putting a lot of thinking into, in fact, how to build this as with an open mind and open interfaces that you can be on this platform and off this platform and yet have interoperability in place. Maybe you want to have, when you go to an organization, this is a tall order to say, to have interconnectivity, to have access to your data across the organization, you shall be on my platform. So we want to, and you have to buy that once, right? You buy this and everything comes to this single instance, a single platform. So to give that autonomy and gradual deployment of this, I guess, this set of tools, we think about you might have one instance or many instances of this operating system, and yet the world should, you should get the value and the interoperability. So we put a lot of thought about this. Idea is that we would want to be contributing We're not saying we're solving all the problems, but contributing to data sharing for analytics and AI at a global scale, across organizations, across platforms, across trust boundaries. And there are many pieces to that. We won't be able to alone solve all of those pieces. So fundamentally, our architecture, when we say it's an operating system, because we expect a lot of people would, and we would open this operating system to from the usage perspective, the APIs are open, and from the, I guess, application or installation on different platforms, the APIs will open, the drivers of APIs will be open, so that the community and different organizations and partners can kind of adapt it to different scenarios, so that we can be a stepping stone toward a global data sharing, not just one company, one organization who happen to buy our product, right?
Right. That would be a bit ironic for sure.
It's very ironic.
Actually, Ryan has a question here, sort of related to Dylan's question. He asks, basically, is it open source, or is there an intention to have this open source?
Our intention is definitely there will be parts of it that are meaningful to be open source. I'm not sure if it's meaningful to have everything open source. That's definitely on our our strategy. Open source takes many different shapes and forms. A lot of projects are open source, but only one company is contributing to it. And there are projects that are open source that are really community driven. Which shape we will get, give us a little bit of time to figure that out. We probably need a bit more time to just be intentional and opinionated about this, and then where it makes sense to open it. There are at least four components that I can see. We have no choice but make it open source and open APIs and get people to contribute. So yes, it's on our roadmap, Brian. It has to be which components and how and when. Stay tuned.
Cool. What other questions look interesting to you? There's no shortage of them.
Well, Abhishek has the question around, it would be interesting to understand how we can leverage sidecar pattern for data governance. So I'll step back. Maybe, Joe, if you want to scroll down to the next part of this, I don't know.
Which one? The page. Okay, yeah.
The page. Oh, yes. Not that part.
Just show me.
Yeah, these four parts, right?
This one?
Okay. Maybe even a letter. Yeah, these four parts. So the sidecar pattern is only meaningful when you have a unit around, like you have a place to hang it off, right? Where does this sidecar hang off today? In fact, in many of our implementations in the past, like the implementation with the existing technology, there was nowhere to hang this sidecar off, because you either have pipeline tasks or you have basically a lake or a warehouse, and maybe at best you can do is put a gateway in front of it. So we have not had that autonomous, self-contained, that quantum of architecture that allows you to put a sidecar. If we just for a moment go back to the history, again, I come from distributed systems, so a lot of my thinking goes back to how distributed operational systems evolved. But if you want to take a lesson as what happened that we were actually allowed to use this sidecar pattern in the API world and in transactional world, there are few key pieces that fell into place. One of those key pieces were that we had this idea of a container, that you have, you can kind of, all of the pieces required to do the job. I run a code, I serve that capabilities of that code as an API, as a container. The second piece that happened with Kubernetes was this concept of pods, that you can have multiple containers kind of running together in the same context, and then you can inject different containers as into those pods as part of the deployment as one unit. So all of these pieces kind of led to this idea that, now that I have a unit that encapsulates a particular function of my business, and I have a very clear interface, inbound, outbound into it, and I have a way of having multiple of those units combined together, then I had this sidecar for service mesh, for OPA, for a lot of different kind of technologies use that idea of the sidecar. In our data world, we don't have that yet. And that's what this idea of a data product container for us is. Let's encapsulate with the intention of that easy developer experience. Let's encapsulate all of these structural components that make a unit of data, a domain-oriented data, discoverable, governed, understandable. Let's encapsulate all of those structural components. Let's create an anatomy of a thing, a skeleton of a thing, that then you can hang off various types of sidecars, right? For example, take policy as an example. Once you have that self-container, you have your APIs to get in and out, then policy engine or policy execution is just a placeholder. Every company has different types of policies. Every industry has different types of, different kinds of policies, different rules. Once you have that placeholder, inbound and outbound, at the write and read and access, then you can have you have a place that then you can open up with interfaces for people to configure and provide code for evaluation of that policy. But we had no choice. Like, I had no choice to say, okay, somebody has to create this. I better go build this. I don't know if that's a business, but that's just so fundamental, so that we can reconfigure data world in this mesh and interconnected way. Otherwise, we're still stuck in that pipeline centralized way. Yes, we sprinkle metadata and some other things to kind of pretend we have data products, but none of these points of extensions can be created so that we can autonomously have these different data products governed and discovered.
Sorry, it's interesting. Sorry, I have to show this comment from Todd. He's thinking about the Wasm play on this. Let's talk, Todd. I was actually talking with somebody about this earlier this week, but the governance part kept coming up over and over. It was the even if you could theoretically have open data sharing, for data products, there's still the governance piece that has to be there. Otherwise, it's an interesting one.
Yeah, well, our thinking is kind of bottom up, right? It's a decentralized way of thinking. It's a bottom up way of thinking as opposed to top down. The top down approach to governing or top down approach to discovering, a top down approach to data modeling is extremely fragile, because each of these people are pieces of data owners, data teams, our data systems are independently changing. So for this mesh paradigm to work, we have to think bottom up, and then we have to think, okay, for all of these ingredients, the atomic units, this data product, what is it that they have to externalize and expose, and so that you can have a top view of the governance. So governance, discoverability, observability, all of that will have a place within this bottom unit of this architecture, which we call data product container.
Right. That's awesome. Let me see what other questions pop out to you. I think we probably got time for one more.
NQ.
What's that?
I don't know.
Okay. Well, I think there was a question earlier.
This is what Perry, perhaps.
What's that? Sorry?
Perry's question might be good. Perry Chen.
Okay.
Is data product dynamic discovery, working with external data ecosystem and across organizations. So every decision that we make is considering there is an data ecosystem. Of course, the data ecosystem might reshape itself, but still there is an ecosystem. One of those pieces of an ecosystem today is data catalogs. I personally don't agree with many of the approaches of data catalog being typed too late, happening, the cataloging, right? The tagging, the curation, stamping silver, gold,
right.
certificates, all of that is too late, too far right after the data has been generated. So while I don't agree with a lot of these approaches, but yet you need to have a place, a window to this mesh. You need to have a place where you can see what these data products are and their kind of behavior and so on. So very early on, we do have, even though we are building kind of discoverability into every data product container, intentionally, every data product is built in with providing dynamic information that makes it not only discoverable, but also understandable, as in providing enough metadata around its timeliness. I mean, all of this in the book, none of this is novel. Though we are doing that, we're building that in the data product, and that's been emitted. You still need to have a place to go and search for this, right? You need a search function, you need a browse function. And I think that kind of browse and search experience is a place that there is an opportunity to plug in right now this information to, cataloging systems that already out there. So we don't feel like that's really the core IP, at least from the intellectual contribution that we can make. That's the search function, and there are many good search tools out there that this can be plugged into, and the existing catalogs could be one. What we want to focus on is that core and nucleus. Of course, we would provide that was just an example. We would provide a search and discoverability tool, but we see that as an example of an extension where you can kind of plug this into existing catalogs. And this example goes on and on. Like the storage, we're not reinventing the storage, data processing, we're not reinventing data processing, but we're removing the need for some things that were only needed when you needed a centralized system. So for example, very complex pipeline management, that's not really needed. So we might remove the need for some of the components of the ecosystem and hopefully help simplifying the ecosystem a bit, but we are very cognizant in integrating with what's out there and not reinvent the wheel.
Right. And there's no shortage of tools out there right now. I would say there's
no shortage of that.
No shortage. Awesome. I think we're coming up on time. I want to, I know you got to hop to a few things, but yeah, I just wanted to, again, give people a quick, a glimpse of your thoughts and so the motivations behind Next Data. I personally think it's super awesome to see this launch. So I guess to kind of summarize, maybe one of the big questions people have is when will this be available?
TBD.
Okay.
We are still fairly early. We want to be on an accelerated path. We don't want to take years before we can actually something out there, but TBD. We will be building this with so right now we're building some of these components with our early customers, with our early design partners. So, and we are very selective about who these folks are to make sure we solve the problem that's not just a point solution, it's a problem that's common across folks. But if your organizations want to be a design partner to us and build this with us and test it in your context and have your fingerprint on the product, reach out to us. There's a Get Early Access, there's a hello@nextdata.com on the website. Get in touch.
For sure. Cool. Well, thanks. And I guess we'll be in Austin next weekend. So at Data Day, Texas. So if anyone's there, come say hi. So awesome. Well, thanks. Kind of an impromptu little get together here on online, but thanks for your time, Zhamak. We'll talk soon.
Of course. Thank you so much. And maybe I just leave some of the questions there. I don't think the problems people are asking, does data lineage disappear? The problems remain. How we solve them will reshape. And how we solve them is going to be, it has to respect the reality we live in, which is world is complex and it's ever changing and it can't be centralized or centrally controlled. So the problem of lineage remains, but we will just solve it differently and hopefully make it much easier and simpler in the process.
I hope so. Yeah, that's awesome. Cool. All right. Well, thanks, Zhamak. And thanks to the audience again. I'm glad this is kind of short notice for everybody, but I felt it was important enough to get everyone together to have this quick chat. So All right. Well, hope everyone has a great weekend, and we'll chat soon. So
Yes. Might see you in Austin.
yeah, Austin.
Take care.
Yeehaw. All right.